Good morning to one and all. Welcome to my channel Firjan. So today we discuss electric field. Electric field. See, electric field due to linear finite charge. Electric field due to linear finite charge in electric charge and electric field lesson 12th standard. See, first we discuss electric field. For that we can take plus q charge at point P or distance from the charge. What is the electric field? Na? Electric field equal to kq by r square. Kq by r square. See, plus q due to plus q at point P or distance from the charge. What is the electric field? Na? Electric field equal to kq by r square. We know already electric field means force exerted on test charge by test charge. So from that we can derive this one kq by r square. So electric field due to plus q is kq by r square. R value changes, this electric field value also changes. See, before that we discuss, sorry, after that we discuss linear finite charge. What is the electric field due to linear finite charge? So linear finite charge, now this is the linear finite charge. This is linear finite charge. Charge is distributed uniformly in this one. See, plus charge is there in this one. See, this length is, total length is capital L. Total length is capital L. See, we can take at particular point. So particular, so not only center. So this length of linear finite charge, length of linear finite charge in this one, we can take a distance from the charge at point P. What is the electric field? We can take, we can find out. For that, here this also not middle, so we can take some particular point. So particular point here, this a distance. What is the electric field due to this charge? So that we find out. For that, what we can do now? See, from here we can draw a line. So it makes some angle theta 1 with this point, initial point. See this one. So makes theta 2, theta 1 this one, theta 2. See, theta 1 covers from here to here, theta 2 covers from here to here, totally covered. See, this is minus theta 2, why not downwards? This is plus theta 2 upwards. See here, in this one, so L distance from this point, we can cut small elemental part. Why not? We know already, only valid for Coulomb's law is valid for point charges only. That's why this part we can cut. This charge is dq and length is dl. From L distance from this one, this point, we can cut small elemental part, that is dq, and length is dl. Due to this dq, what is the electric field now? See, that electric field at point P is dE. dE is the electric field due to dq charge. Due to dq charge, it makes angle pi only, pi angle. See here, it now it will be extended. So what now here making pi angle? Why now here angle pi, here also pi. See, this dE has two components is there. One is dE cos pi, another component is dE sin pi. It is sin pi, it is cos pi. So why not? Which side theta is there, that is dE cos pi, opposite na dE sin pi. We have here two components. One is perpendicular component. It is perpendicular to this linear charge. This is actually horizontal component, it is vertical component. For this linear finite charge, it is perpendicularly. Electric field, what is the perpendicular to this linear finite charge? Na dE cos pi. Parallelly what na dE sin pi. So this is the electric field due to dq charge. Like this we can cut here dq, all now we can add, we get the total electric field. So for that, first we find out this one. So later we can take integration, we get the total electric field due to this finite linear finite charge. For that, what we can write now? dE we can write. So dE means due to this dq charge dq, what is the electric field now? dE electric field. So small dE. Why not small dq means point charge, only point means elemental part. Due to this elemental part, what is the electric field now? Actually formula is what? K q by r square. Q means here dq, r means here this is a small r distance. It's not small r distance from this point. See, K charge is dq, K dq by r square. This is the electric field due to this dq charge. So k dq by r square. Before that, see here we can discuss here linear charge density. Linear charge density means lambda equal to q by n, charge per length. Charge per length. Charge is what here dq, length is what dl. So we can write dq by dl. We can write what is the lambda value. Linear charge density is dq by dl. So from this dq equal to what we can write, it will be changes to here lambda dl. dq equal to lambda dl. dq equal to what? Lambda dl. See next one more point. See here dq we can find out. What is the dq value? Lambda dl. We can keep this aside. So later we can use this one. See next here we write here from this triangle. See this is the triangle. See here we are getting it is pi angle. It is r. It is l. It is a. See from this what we can write? Cos pi we can write. Why now we want this one? We use all these points. Cos pi na adjacent by hypotenuse. Adjacent is here what? A. Hypotenuse is r. Means from this r equal to what we can write? A by cos pi we can write r equal to. So means this radius equal to what? A by cos pi. A by cos pi. So one more we can write, that is from this triangle tan theta we can write. So tan theta equal to opposite side by adjacent side. So opposite is what? L, adjacent is A. So from this what we can write? So L equal to A tan theta we can write. A tan theta. L means here this length. See L we can differentiate with respect to pi. With respect to pi we can write. See what we can write? dl equal to a secant square pi d pi. Secant square pi d pi. Secant square pi d pi. See once again. So from this triangle what we can do now here? This is length L or a. We can write tan theta value opposite by adjacent L by a. Tan pi equal to, from that L equal to a tan pi. So differentiating with respect to pi means dl equal to a secant square pi d pi. See here dl we are getting, what is the dl value? A secant square d pi value. So r value a by cos pi, dq value lambda dl. See we have here de. What is de? K dq by r square. In this one we can substitute this all values. We get so one expression. See here I write here de equal to, so means electric field due to charge dq. This charge, what is the electric field na? K. Instead of dq what we can write? Lambda dl. Lambda dl we can write by r square. Yes na? See de equal to k lambda dl means what? Here we get a secant square d pi. I write here a secant square d pi. A secant square pi d pi we get by r square. So means r value what we are getting? A by cos pi, means a square by cos square pi. See why we are writing now this and all will be converted into one variable. For that we can do this and all. See here a cancel, cos square pi secant square pi cancel. So what is the de value now here? K lambda by a d pi we are getting. K lambda by a d pi we get. See here de means this de value what we get na? See k lambda by a d pi. After simplification we have two components is there, perpendicular component and so parallel component, means perpendicular to this one. So what? De cos pi. So e perpendicular we can write. Parallel to this linear finite charge na? De sin pi. See in this one first we find out perpendicularly. This one we can find out. See perpendicular electric field. See here this dq means this value we get. This type of how many is there? So many is there infinite. From theta 1 angle many is there. From theta 2 by theta 2 angle also many is there. So for adding that all d is, we can write it as integral. We can write integral de. What is the perpendicular here electric field for this linear finite charge? De cos pi. See de cos pi. See here de means this is the value k lambda by a d pi. See I write here integral k lambda by a cos pi d pi. Now we know DE how we get. So we can simplify this and all, we get the DE value. So that I write k lambda by a cos pi d pi. So what is the interval now? Upper one is theta 1, lower one is minus theta 2. And downwards we can take minus here. See, minus theta 2 to plus theta 1. So this is the interval. Now I write here, see. So electric field perpendicular to this linear finite charge is k lambda by E is constant. I write outside. So interval integral minus theta 2 to theta 1 cos pi d pi. Cos pi d pi. See, integral cos pi na sin pi k lambda by A sin pi. Interval is minus theta 2 to theta 1. So what we can write? K lambda by A. So sin pi na sin theta 1. Instead first we can write upper interval, later lower interval, minus sin of theta 2 minus sin theta 2. So minus of sin of minus theta means minus sin theta. Already minus is there. We can write k lambda by A sin theta 1 plus sin theta 2 means what is the electric field perpendicular to linear finite charge na k lambda by A sin theta 1 plus sin theta 2. This is the electric field perpendicular to linear finite charge. Linear finite charge. What we can write now here? See, first we can write this is the total length L. So at some point, so means some at some point on the linear finite charge, so some distance a distance from this finite charge p point, we find out electric field. For that we can take L distance above this point. So dq, not this is not midpoint, so we can take a particular any particular point. So dq length L at length above L length above this point. So dq means elemental part we can cut. This is elemental charge dq. Due to this what electric field dE, it has two components. One is horizontal or vertical. So horizontal is dE cos pi. Why? Because here pi theta is there. Which say theta, that is pi cos pi. Cos theta we can take, other opposite is sin we can take. So dE cos pi, it is dE sin pi. This dE we want to find out. dE means what? Due to this dq na, so that we can dE means k dq by r square. So dq we want. dq how to find out? Linear charge density equal to charge per unit length dq by dl. From that dq equal to lambda dl. I write here lambda dl by r square. R means here from this triangle we can take here AL R is there. From this cos pi means adjacent by hypotenuse a by r. R equal to what? A by cos pi. So means wherever r a is there, there we can write a square by cos square pi. So we can get here somewhat. Select. From this we can write tan theta. Tan theta means what? Opposite by adjacent, L by A. L equal to A tan theta by A tan pi. So differentiating with respect to pi. So what we get? DL A. Tan means secant square pi, means d by dx of d pi of tan means secant square pi d pi. So this value we can write instead of dl a secant square pi d pi. R means a, or means a by cos pi. So means cos square by a square by cos square pi. Cos square secant square cancel, a cancel. What we get? d equal to k lambda by a d pi. So this d value is k lambda by a d pi. Now we find out perpendicular to this linear finite charge electric field. So that perpendicular na this one. Say k lambda by a cos pi d pi. K lambda by a is constant. We can write out. Cos means sin pi. Upper limit first, lower limit next. So cos sin theta 1 minus sin of minus theta 2. So means minus sin theta we get. So minus minus can plus. So means sin theta 1 plus sin theta. This is the perpendicular electric field to the linear finite charge of this linear finite charge, due to linear finite charge. See, parallel we can write. So parallel equal to what? DE sin pi. I write here DE sin pi. This also have many is there, infinite is there. We can add, so we can take integration. Integral minus theta 2 to theta 1. So DE na, DE means here we can write. So k lambda by A. No, here k lambda by a d pi. So means sin pi d pi. See, integral minus theta 2 to minus theta 1. See, k lambda by a is outside we can write. So means constant k lambda by a. Yeah. So sin pi means integral sin pi d pi. So means here theta 2 to theta 1. Sin theta means so minus sin sorry, minus cos pi. See, minus cos pi, interval is here k lambda by a is there. Yes, na? See, interval is minus theta 2 to theta 1. See, final step I write na here. See, k lambda by a upper limit theta 1. So, minus cos theta 1 minus of minus na plus cos of minus theta 2, cos of minus theta 2, cos theta 2 only. So that's why k lambda by a cos theta 2, first this one we can write here minus cos theta 1. So this is the parallel electric field. Electric field is parallel to linear finite charge. So that is E parallel equal to k lambda by a cos theta 2 minus cos theta 1. Perpendicular na k lambda by a sin theta 1 plus sin theta 2. This is the electric field due to linear finite charge. Linear finite charge. Now we discuss electric field versus X graphs we discuss. See in this class, see what is the electric field versus X graph. Before that, we discuss electric field. Electric field we know already. Electric field is inversely proportional to distance between them. Distance. So that we can write here. See from that. So first we can take plus Q. See at P point, what is the electric field now? K electric field equal to KQ by R square. So means R distance now. So that's why. See for that, see for example, electric field R tends to 0 means electric field is maximum. R tends to infinity means electric field is minimum. Minimum means 0. Why? Because KQ by R means infinity. Na? Infinity square means KQ by infinity, that means 0. Means R value 0, E is maximum. R value maximum, E value 0. E value 0 means E electric field near to charge na maximum, far na 0. See, we can take here plus Q charge. For this we can write E versus X graph. See here y axis electric field, x axis distance, x we can take. See electric field is inversely proportional to its distance. Yes, na? See R value 0, E value maximum. Yes, na? This one first point. So second one, see R value is infinity, E value is 0. Second one. See one more here point. This direction we can take it as a negative electric field. Sorry, positive electric field. This direction we can take it as a negative electric field. Negative electric field. See, we can take here plus Q electric field. So electric field, how it is? It is moving towards the charge. Towards charge means, sorry, away from the charge. Away from that means electric field is this direction. This direction means right direction, positive. Electric field is positive. Positive na starting maximum. After that, what happened? Distance increases na, so value decreases. So this is the graph between E versus X. For example, see this side. So electric field is outwards. So means electric field is away from the charge. Away from charge means this is the direction of electric field. So means we can take negative. Negative na. This is the negative electric field. Yes na. See, this is the graph for positive charge. This side is this one. So right side is positive and the electric field is this. Negative now, why now away from the charge. So this is. See, for example, now we can take minus Q charge. Minus Q charge. See electric field along x axis, x distance is y axis. See, it is electric field. Here electric field. Minus Q na. See electric field is towards the charge. So means towards charge means negative. Negative means this one. See, this is the electric field versus X graph. For minus charge, minus Q. See, for minus Q this side na, so electric field is this direction, means positive. So positive means this is the graph. This is the graph for right side. Yes na? See, this is the graph. Yes na? Minus Q is this one. Plus Q is this one. See, now we can take plus plus, we can take it. See, plus charge and plus charge. See, plus Q here I can take. Here one more plus Q. See, due to this, what an electric field we can write it. See this one plus Q na electric field. See here electric field, y axis is electric field. electric field is away. Away means positive. Positive means this is the graph. Yes, na? See this side, electric field is away, so means negative here. So why? Because this left direction, so we connect negative now. So this is the graph. See, this is the graph as a negative electric field. This is downward is negative electric field. See next positive now, this one electric field, this one. So electric field is away. Away is electric field means positive, so we can write it. Yes na? See here how it is now. See, like this we can get graph. It's now for plus q plus q. See this direction, electric field is away, so means negative. See the right left direction, so means this is the negative. This is the graph for E versus X for plus q plus q. This is positive, it is positive, this one is negative, so both join here. So this one negative, this is the plus q. See minus q we can take now here. See minus q charges. See minus q we can take here. See here minus q we can take. See electric field is y axis, distance is x axis. Here electric field, here see this one minus q now here. So electric field is towards means here negative. Negative means this is the electric field. See here this direction, this side electric field is towards means this right direction means positive. Positive means this is the electric field positive. Yes na? For this electric field, see towards means negative na, this one. See we can join these two. See here, join these two, what na, like this will come graph. This is the graph for minus q versus minus q. This one, see here electric field is towards, so means positive. Positive means this is the graph. This is the graph for E versus X for minus q charges. So what is the electric field versus graph X graph now? This one. So plus q na, this is the graph. So we can take plus q minus q, we can take now plus q minus q. See here I take plus q, here I take minus q. See graph now, see here electric field is x axis, sorry electric field is y axis, x axis. Electric field, see it plus q na, towards means negative means this one. It's a negative electric field, it is a negative electric field. See this one, so electric field this side na, towards means positive side, so means positive. So this is the graph. Yes na? See this is the graph. See now plus q na, see electric field y axis na, electric field here, this is the away from the means away means positive means this one. So this is the graph for minus q plus q. Now see plus q na, electric field is away means positive, sorry negative, sorry this na, this one. See here this is the negative na, downwards is negative. See this is the graph between E versus X for plus q minus q. We can take here plus q and 4q means different, not same magnitude. So we can take plus q and 4q, we can take 4q means charge plus q, plus only, here also plus, here also plus. So but here magnitude is changed, how the graph is here. See for example here, see electric field this one. So electric field na, which direction here? Away means positive na, this one. This is the graph. Yes na? For example this side na, electric field is away, so means negative means this is the graph. It's not negative direction, negative electric field. See for this plus na, electric field is here, electric field is plus na, away means positive na, this positive side is there, so positive, so means this is the positive. It's now both added now here. See here we can use means this plus 4q have more electric field, plus q has less electric field. That's why here both combined. It's not this one. His maximum. See this one. Like this graph will come. See for this now this side electric field away means here positive. Sorry negative. Negative means this is. This is the graph for plus q plus 4q. This is for my plus q minus 4q. These are the graphs for electric field versus x due to charges. Okay, thank you.